So yes, this Ignite is Power Your Cloud. So most people think about cloud and they think about open source, which is very known in DevOps. But when you think about open source, you typically think about open source software. This talk is about open source hardware. So yes, I like to build stuff. So I use this acronym to build your own data cloud. That can be in a public cloud, that can be your private cloud, that can be hybrid cloud. But by trying to impose those clouds to use open source hardware, we can actually have more open source hardware available. And also that will trickle down into more commercially available retail devices. So one of the examples I will be talking about is Open Power. And now, of course, there's also CXL, which is the open source accelerator behind it. So this technology basically is now completely open source, which means you can go to the website and you can actually find the instruction set. You can build a processor compliant with this instruction set. It's a RISC-based processor in place of a CISC-based, so it's more aligned to the ARM ecosystem. It was originally developed by IBM, but now it's in hands of the foundation, which is under the Linux Foundation. So previously it was Big Endian for people who are more technical. Little Endian is the more commonly used one, but it's now BiEndian, so you can use any code anywhere. At least it should be portable for all software. This is some history about how much threads you can have on a machine. So if you want to go to higher scalability and if you want to have more sustainable data centers, this is a better solution because it's much more dense possibilities. Like I said, it's all open source, so even the firmware is open source. You can actually go to GitHub and look at the Opal repository. You'll see there host boot, ski boot, and petite boot, which basically initialize your system. So if you don't like the way that your system is being initialized, you can actually change that. You could change how your fans work and change the temperature arrangement so that you can actually save some energy on that. The other part is the BMC. So there's a project called OpenBMC, and there's a project that we now started called LibreBMC. OpenBMC being the software stack, LibreBMC being the hardware stack, which means that you can actually have an FPGA which you program yourself and you can manage it yourself. That means you have full control over the system. There are no hidden components like in other machinery, which means that we can actually own what we have and not be hijacked by other people. These are some of the companies that run it. So obviously IBM as one of the core creators, but you have companies like Raptor which make more affordable machines, or Red Semi which is building a smaller type of machine which is more the retail and commercial end perspective of it. The software stacks that run it are these distributions. So you see it's almost major distributions have it available. We also have now the BSD community joining in, so they are also becoming available on it. So if you look at that, if you look at your normal traditional open source ecosystem, typically everything will run on this type of machine. One host machine typically can run about 1,024 VMs. If you run containers, it's much higher density on that. Like I said, most common open source software is currently available. So if you go to any popular distribution, you'll find them in there. Porting is typically very easy as it's majority of the time just recompiling, unless you have somebody who specifically wrote system-specific code. So yeah, these are other examples of software that has been tested. If you're already using any of these softwares and you want to have higher densities, that's much easier. One of the clusters that MariaDB tested, they were able to get 1.5 billion transactions per second. So if you really need that speed, you can get it out of this type of machine. And also all the other programming languages. So we now have support for Rust and Golang. So most of the newer type of software is available, but also any of the older stuff is also still available on it. And so in this way, we are trying to create an ecosystem that supports all open source software, but would be available on open source hardware where you could find the design, you could know what is happening, and you could understand what is running on your system. Thank you. One other little thing which is not part of the slides, we as in Chris and I run another conference called Config Management Camp, which is about infrastructure as code. Our CFP is open. There was some tweeting about it. Registration will also open very soon. So if you're interested, please check it out. Thank you.
Thanks, Toshaan.